So that kind of cuts us over to the next topic, SSD and flash and the data reduction technologies that are disrupting the storage market and moving beyond tier 0 and tier 1. What do you think about that?
Well, and I'm in fact in the middle of doing a paper for a client about storage efficiency. And so I started thinking about data reduction, deduplication and compression. And I think we've reached the stage where there's no reason not to compress.
Oh yeah, I agree.
That we have plenty of CPU horsepower in the storage system to compress the data. Decompressing the data actually does not take much CPU horsepower.
Yeah.
That the algorithms are written such that it takes a little bit of compute to compress, but it hardly takes anything to
decompress.
And
you get an advantage because you're moving less data around the system too, right? Yeah.
Right. And so it's long been, even back to things like Stacker in the DOS world where we were dealing with ridiculously slow hard disks. Mm-hmm. When you have an ST506 hard disk spinning at 2700 RPM with 100 millisecond average access time,
ouch.
Trading, but the trade-off of doing less IOs because the data is compressed actually improved performance.
Yeah, I agree. We had the same phenomenon on Iceberg. We had hardware compression in those days, and we were just moving half as much data as the rest of those guys. So we had better cache configurations because of that,
right.
et cetera, et cetera.
It makes if you don't decompress it till you deliver it to till it leaves the system, well then the cache becomes effectively larger.
The data transfers become effectively faster, et cetera, et cetera. Yeah.
Right. The problem becomes deduplication because reading from a deduplicated data store is 150% random.
150% random. Absolutely. I agree.
It's just, there's no such thing as sequential IO reading from a deduplicated data store. Yeah. Every, and the finer grained you get, the more random the IO becomes. So you have to trade, so if you have disks, which do random much slower than they do sequential, then deduping to disk is a performance problem.
Right.
On the read side. But if you have flash, which do random at least as well as they do sequential,
maybe even better.
Well, with many SSDs, there's like a 5% better. Random reads are like 5% better than sequential reads because they can parallelize across the back end channels to the multiple flash chips a little bit better. Right. But if in that case, deduping has no performance penalty; it just has a CPU penalty. And so what we're seeing is in the all flash market, data reduction is table stakes. Not everybody does both dedupe and compression yet.
Right.
But everybody is saying by the end of 2015 that our systems will do both. And we've got, vendors like HP with the 3PAR not only saying, we'll be doing this in a reasonable period of time, but also that systems you buy today, it's going to be a firmware upgrade.
Yeah. And they're doing it to some extent with FPGA assists and stuff like that, which make it a little bit
right. Well, no, and they're doing dedupe, not compression right now, and they'll the other is a firmware upgrade. The problem is when you start talking about a hybrid system, and because in a hybrid system, the cache miss is falling off a performance curve.
Right. From microseconds to tens of milliseconds at best.
Right. And then if we're also falling off that performance cliff to not milliseconds, but tens of milliseconds, because we're rehydrating the data.
In addition,
that might not be such a good idea.
Right. So you're thinking there's a solution here that
we're seeing hybrid systems that reduce the data in the flash layer and then say disk space, because we're using 7,200 RPM drives,
Cheap and
is
cheap.
so cheap
Yeah.
that we would rather not take the performance hit for deduplicating the data on the disk. And that has some advantages. My problem is, it doesn't work with some of my favorite techniques in the VDI space. I like to do full clones on deduplicated storage, and then just go, look, it's another PC. It's a virtual PC,
Right.
and we're going to manage it with LANDesk or Case or SCCM, because we're never going to get rid of the physical PCs anyway, and at least this way, our physical PCs and our virtual PCs are managed the same. So, for that, you need to deduplicate all the way down.
Right.
The part that I'm of mixed minds about is doing this in the hyperconverged world, because all the CPU that you use for data reduction,
you're also using it for compute. You're also using it for storage.
if it was a storage system, then
we got plenty
all
of
all I have to do is not let a customer buy so much capacity that the CPU and my controller won't be able to handle it.
Right. Or scale
and so if
both,
And so if you look at like Pure, that's their scaling limit. Is one system can only get as big as the horsepower of the controller to manage it is.
Yeah. Lots of systems out there like that.
Right. But with Pure, it's because it's dual controller, it's kind of most visible.
Yeah, I agree.
And but that's always been true of dual controller systems. And that means that it's really weird if you're, a VNX, where there is a certain point at which you have more drive slots you could put flash in, but the controllers won't be able to keep up with it anymore.
Well, there are a couple of vendors out there that actually, right. There are a couple of vendors out there that actually talk about the maximum number of SSDs you can have in a controller system. Not everyone does that.
No, and frankly, that's just them being honest.
Right. Absolutely.
This is true for everybody.
That's true.
And so some vendors will just put right on the spec sheet, you have 100 slots and 12 of them can be full of SSDs.
Yeah.
And the other guys will say you have 100 slots and you can put SSDs in some of them.
Yeah. Something like that, Absolutely.
But in the hyperconverged world, that CPU, if I use that CPU for data reduction, then that means I can support fewer VMs.
Yeah.
And that's a trade-off people don't get yet. In part it's because only a few vendors are doing data deduplication in the hyperconverged world. In part it's because we're still at the phase where most people have CPU to spare in their hyperconverged systems.
Right.
Because they're not using them for serious applications. But, imagine an all-flash hyper-converged system.
There are a couple, not many.
There are a couple, but you have 12 SSDs in each node.
Yeah.
Well, SolidFire takes that whole server
to do its stuff.
To run 12 SSDs.
Right.
Just as a storage system. And I have to believe that if they could cram more SSDs in there with the same server and deliver the performance that they want to, they would do that.
Yeah.
And so for me to go, and I can run 100 VMs as well, I'm having trouble believing that 100 VMs using the 500,000 IOPS that system could deliver, that those CPUs aren't going to get trashed someplace.
Yeah.
So,
well, it's just a matter of more cores and more processors, and and our friend Intel is constantly upping all that stuff.
Yeah, well, I mean that's actually my latest blog post was I sat down and I looked at the Dell R730, so the current Haswell generation of processors. And there's about a factor of 4 performance difference from not the cheapest one you could buy, but from the one most people buy, the
To the top end?
E5 2620, the processor choice they made for Evo Rail,
Right.
which is 6 cores, or the 2699, which is 18 cores.
Well, God, it should be a factor of 3 at least, right? You would think.
And so if you multiply the cores times the clock speed and
Yeah.
the amount of memory, it's about a factor of 4 difference between a small server and fully blown out.
Yeah.
Um,
You see the advantage to some extent of these multi-core environments running hyper-converged workloads
well,
with
just
data
running
reduction.
virtualized workloads.
Yeah, you've got a lot of
You
different
say
threads.
I've got 36 cores with hyperthreading, so I've got 72 threads
Yeah, you can
on a
potentially run,
fully
right?
blown out system.
Yeah,
I could easily run 100 VMs on that,
yeah.
and everybody could have their own, every
Threads at
process that
least.
had
Yeah,
to run.
yeah.
The interesting part, though, is when you start looking at the software licensing,
Ah,
because if you put vSphere Enterprise Plus and 3 years of maintenance and Windows Data Center Edition, which you need to license the Windows guests, and Veeam Enterprise Edition, that's like 20 grand MSRP per server.
per server, okay.
And they're all licensed per server or per socket. So doesn't it make a lot more sense to spend 40 grand on the fully blown out server
Yeah,
than
yeah.
28 grand on the little one, but
And have to buy more. Yeah,
you have to buy more of them.
yeah.
So, how big a cluster do you build? Well, you need enough that when one fails, it doesn't really impact things. So, 6.
Right.
So I want to
Yeah.
cluster. I want to cluster 6
Servers.
to 28 nodes.
Yeah.
Because 32 is the limit, and I don't want to buy it at 32 because if I, got to leave yourself a little bit of growth room.
Yeah.
But as long as I'm within that range, I kind of want the biggest server I can build.
Yeah.
So
but
that
getting back to the discussion here, I mean, with the multiple cores and all that stuff coming out, even a hyperconverged with SSDs with data reduction, potentially possible, but you have to divvy up that world, right, properly and be able to take advantage of all those multiple cores and not burden the VM workload, right?
Yeah. And I'm of mixed minds about the whole hyperconverged model. People have predicted that it's going to take over and be the general case. And I'm thinking it's going to be more like blade servers.
Huh.
That there's like a 30 to 35% use case where that's the right solution.
Why? Why do you say that?
Because the economics don't work.
Because of the software license.
Because if we're talking about vSAN's $24.95 per socket plus maintenance. So for every node in my network, I'm buying $5,000 worth of software.
Yeah.
To run vSAN.
Right.
Well, that means that when I have 4 nodes, the cost of vSAN and the SSDs and the hard drives becomes comparable to
a storage system.
Small,
yeah.
I did an article, a post on network computing, and the bottom of the line TGILE, which is not it's a hybrid system. It's perfectly reasonable.
Yeah, all that stuff.
But 4 Dell R720s and the bottom of the line TGILE came out to be about the same price as one Evo Rail. But it had 3 times the capacity.
Yeah.
And when you start saying, okay, so what about if I go to 5 Evo Rails, 20 nodes? Well, then the top of the line tin tree
Okay. Yeah.
becomes over $100,000 cheaper.
Oh God.
With buying the servers configured the same way and all the software. And so, why do I want to build with these building blocks that, they only come in one size, or even if we go to like Nutanix, they come in 5 or 6 sizes of, relative CPU to storage.
But it's the software licensing that's killing you, as much as the hardware. That software license is killing you.
It's
That's
a software
why
license.
something like
but remember, if I'm talking about a Tgile or a Tintry, that's just software.
Well, yeah.
Neither one of those vendors builds custom hardware. That's a storage bridge bay cabinet that they buy from Xyratex or Supermicro, and some NV DIMMs or a NV RAM card and software.
Yeah.
And it's the difference is just packaging.
Right.
So I'm a big believer in software defined storage. I'm a big believer that, but I think that the place where hyper-converged makes sense is the SMBs and robos.
Oh yeah,
where
perfect.
Where you're talking about, first of all, if we're really talking about the robo market, where it's a big box store, 2 nodes is plenty. How many virtual servers do you need to run 30 cache registers?
Right.
And so a bunch of the current hyper-converged solutions don't scale down that far very well. vSAN absolutely requires 3 nodes. It would be better with 4.
Right. That's where something like scale computing that kind of avoids a lot of the software licensing costs and stuff like that, but provides a reasonable virtualization environment and stuff.
Scale computing, grid stored, Nimbox.
Yeah, those guys.
If you really like VMware, Store Magic or the HP left-hand VSA.
Right, those kinds of guys.
Where it will support 2 nodes. And, frankly, if I'm doing 2 nodes and the cost of a hardware RAID controller is insignificant to the cost of the solution.
Right.
So I'll run 2 nodes with RAID 6 and replicate between the 2 nodes.
Right.
And really have built-in suspenders, because it was another $4,000 in a $100,000 project.
Yeah.
And and it's robo, and it's going to be a day and a half till I can get somebody out to the East Willanocket plant.
Remote center. Yeah.
So I want built-in suspenders.
Yeah.